Do you feel like pulling your hair, your kid's hair, your pet's hair, because your math homework is driving you crazy? Fantastic! We can help you avoid having all that hair and fur on your clean floors by watching this video by Fort Bend Tutoring and Mr. Witt.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about verifying trigonometric identities part 2. That's right, this is going to be a 4-part series, and in this second part I bring you 8 more verifying trigonometric identity problems for us to solve together. So in number 1 we have 1 minus cosine squared theta divided by cosine theta equals sine theta tan theta. So normally, ladies and gentlemen, you're going to attempt to either change everything into cosine and sine functions, or see if you can identify a trigonometric identity property that will give us a clue as to how we should tackle the problem. Well, in the numerator, I see that we have 1 minus cosine squared theta. Well, that's just your Pythagorean identity that's been rewritten. That means that this 1 minus cosine squared theta can be substituted with sine squared theta. Exactly. So I'm going to rewrite this as sine squared theta over our cosine theta here. All right. Once I have this, ladies and gentlemen, I'll be able to then separate this, expand this into sine theta over 1 times sine theta over cosine theta. Just like that. Then using your quotient identity, all right, or your tangent identity, you should know that sine theta divided by cosine theta is just tan theta. It's the same thing. So I'm going to go ahead and simplify this left side to give me sine theta, and once again that quotient, that sine theta divided by cosine theta, yeah, that's tan theta. It's the same thing. So I'm going to bring down that tangent theta, and we're done. There it is, ladies and gentlemen. Left side now equals to the right side. Done and done. All right. Well, that was problem number 1. Let's move on to our next one. All right. In problem number 2, we have tan squared theta divided by secant theta, and that's supposed to equal to secant theta minus cosine theta. All right. So the first thing I'm going to do once again is I'm going to either attack the problem by changing everything into sine and cosine functions, or I'm going to see if I can identify a trigonometric property that I can use that'll help me break this down into our result that we'll have on the right side, which is that secant theta minus cosine theta. So what I'm going to do first is I'm going to recognize that this tangent squared theta is part of a Pythagorean identity. Yeah, in fact, the tangent squared theta, it's equivalent to secant squared theta minus 1. So I'm going to rewrite that. I'm going to use substitution. I'm going to rewrite this as secant squared theta minus 1 all over this secant theta, just like that. All right. From here, ladies and gentlemen, I'm going to expand this. That's right. I'm going to rewrite the numerator over the denominator separately. So I end up with secant squared theta all over secant theta minus 1 over secant theta. All right. This is what I have thus far. Then, simplifying this even further, we know that since we have secant squared theta divided by secant theta, that when you divide those, that the 2 minus the 1, as far as the exponent is concerned, is going to be simplified to give you 1 secant theta. Yeah. In other words, this goes in here 1 time. Exactly. So you can simplify that down to secant theta. All right. And then I'll be bringing down this negative sign here, and 1 over secant theta is cosine theta. That's utilizing that reciprocal identity. All right. So I'm going to put that down here at the bottom to remind you guys, as I will every other property I use in this video. And that's our answer. Secant theta minus cosine theta. Done. That's it. I'm going to put a check mark right there to let you know that the left side has now been verified into the right side. You got it. They equal one another now. I'm going to move on to the next problem. That was problem number 2. Yeah. All right. Problem number 3 coming up. Here we go. Here we go. Here we go. Check it out. In problem number 3, we have sine to the 4th power x minus cosine to the 4th power x equals 1 minus 2 cosine squared x. Well, ladies and gentlemen, what I have before me on the left side of the equal sign is a difference of squares. That's right. I have a perfect square minus another perfect square. Well, we're going to definitely try to factor this, all right? So your factoring properties that you've learned along the way will definitely come in handy as you're verifying trigonometric identities, all right? So recognize that your left side here is a difference of squares and factor that out. So our left side becomes sine squared x plus cosine squared x times sine squared x minus cosine squared x. All right, just like that. Okay, well, sine squared x plus cosine squared x is one of your Pythagorean identities, all right? So it equals to 1. Yeah, I now have 1 times this sine squared x minus cosine squared x. All right, so that's what I have thus far. Well, knowing that 1 times anything is itself, I know that I will just end up with sine squared x minus cosine squared x, but look at what they want us to have on the right side. They want us to have the 1 minus 2 cosine squared x, and I know doggone well that sine squared x is not part of my answer, so how can I rewrite sine squared x with a cosine squared x? Well, using that same Pythagorean identity, if I were to solve for sine squared x, I would end up with 1 minus cosine squared x minus my existing cosine squared x. All right, so keep in mind all I did was distribute the 1 and it didn't change everything, and I ended up with just sine squared x minus cosine squared x. And what we did from there was I was able to replace this sine squared x with 1 minus cosine squared x, and then I just brought down that negative cosine squared x from there. At this point we have like terms. Yeah, right there. Those cosine squared x's, they can combine together. So what you'll do from here is you'll bring down that 1 and then negative cosine squared x and another negative cosine squared x combine to give you a negative 2 cosine squared x, which is exactly what the right side of our original problem is. And so we're done at this point. That's it. Left side equals to the right side, ladies and gentlemen. That's supposed to be a check mark right there. There it is. There's your check mark. That is problem number 3. Done and done. All right, moving on. In problem number 4, we have cosine squared x minus sine squared x divided by 1 minus tan squared x. And this is supposed to equal to cosine squared x. All right. Well, first thing is, ladies and gentlemen, that I noticed that we have tan squared x in the denominator. And I'm thinking I want to change everything into cosine and sine. Yeah. That's exactly what I want to do. So I'm going to rewrite this tan squared theta using my quotient identity here. And I'm going to say that my numerator stays the same. So it's cosine squared x minus sine squared x all over this 1 minus. And then using my quotient identity, I'm going to change that tan squared x into sine squared x over cosine squared x. Just like that. All right, so now with this complex fraction, this fraction within a fraction, I want to get rid of that. So I'm going to multiply the numerator and the denominator by cosine squared x over cosine squared x. In other words, I'm multiplying by 1 in the form of cosine squared x over cosine squared x. And this is a multiplication symbol right there. There you go. So I'm going to be multiplying straight across, okay? So we don't have to get too fancy with this. Just go ahead and put your cosine squared x in front of that binomial. So I'm going to rewrite this as cosine squared x times cosine squared x minus sine squared x. All right, and all of this is going to be over cosine squared x minus sine squared x. So how did we get here, ladies and gentlemen? I multiplied the 1 times cosine squared x, and that just gives me cosine squared x. Then when I multiplied a negative sine squared x over cosine squared x times cosine squared x, the cosine squared x is, yeah, they canceled out, okay? And that left me with a negative sine squared x. So I'm distributing the cosine squared x to each and every term, except that in the numerator, I knew that it was going to be a bit more complicated, so I just left it as cosine squared x times that existing binomial, which was the cosine squared x minus sine squared x. All right, I really only distributed in the denominator. All right, just letting you know. And the reason for that is because we now have an identical factor over itself. In other words, that cosine squared x minus sine squared x is now over cosine squared x minus sine squared x. And guess what? That cancels out now, ladies and gentlemen. Yeah, it cancels out, which means that our result now is just going to be cosine squared x. And that's it. That verifies this problem. Done and done. All right. Okay, ladies and gentlemen, here we are. In problem number 5, we have 1/2 cotangent x over 2 minus 1/2 tangent of x over 2 equals cotangent of x. Isn't this beautiful? Isn't this beautiful? So what we're going to be doing here is we're going to be using our half angle rules right here, our half angle properties, and that is what's going to make this problem different than the other problems that we've done thus far, because we haven't had a problem where we used a half angle property. All right, so make sure you're paying attention at the bottom here for these properties that I'll be implementing. So my first step here, let me show you what I'm going to do. I'm going to first of all expand each of these terms. I'm going to show that I have 1/2 times cotangent of x over 2, which is equivalent to 1 plus cosine x all over sine x. All right, and once again, I'm using those half angle identity properties that you should have been introduced to in your class. All right, if not, I'm introducing it, and it's right here at the bottom of your screen. Okay, then continuing this process, I'll have minus 1/2 times, and then tan of x over 2 is equivalent to 1 minus cosine x all over sine x. All right, just like that. Okay, now that I have this, what I'll do from here is I'm going to multiply straight across now. Okay, so that means that 1/2 times that 1 plus cosine x over sine x is going to be equivalent to 1 plus cosine x all over 2 sine x. This is going to be minus, then multiplying straight across again, 1 times 1 minus cosine x is 1 minus cosine x all over 2 times sine x, which is 2 times sine x. All right, just like that, ladies and gentlemen. Continuing on. Now that I have a common denominator, I'm going to combine these numerators together. All right, and when I do that, I have to keep in mind that this negative here, that minus sign, will be distributed to everything in the numerator here. In other words, I got my arrows popping, ladies and gentlemen. All right, so I'm going to combine those numerators. I end up with 1 plus cosine x, and then a negative 1 times 1 is negative 1. All right, and then a negative times a negative gives me a positive cosine x. All right, all of this is over 2 sine x, which is my common denominator. From here, my 1's will cancel out, all right, because those are additive inverses, right? And then I can combine those cosine x's, and I have cosine x plus cosine x, which is 2 cosine x, which is currently over our common denominator, which is 2 sine x. All right, so that's what we have thus far. Now, check this out. We can cancel out these 2's. They're gone now. And we know that cosine x over sine x, yeah, using those quotient identities, that's cotangent x, ladies and gentlemen. It is cotangent x and done. That's it. Left side now equals to the right side. That was problem number 5. All right, that was fun. Next problem. Problem number 6. Here we go. All right, in problem number 6, we have tan theta divided by 1 minus cotangent theta plus cotangent theta over 1 minus tan theta equals 1 plus secant theta cosecant theta. All right, ladies and gentlemen, in problem number 6, what we're going to do first is we're going to utilize our reciprocal identity only in this first problem, in the denominator there. That's it. So we're going to start out by doing this. We'll have this rewritten as tan theta over 1 minus 1 over tan theta. All right, using that reciprocal identity. Plus, and I'm going to leave this second fraction the same. This is going to be cotangent theta over 1 minus tan theta. All right, so this is going to be my first step thus far. All right, the next thing we want to do is we want to get rid of this complex fraction. So what we'll do is we'll multiply each and every term in that first fraction by tan theta. So now what we'll do is we'll multiply the numerator and the denominator by tan theta. All right, the second fraction, I want you to leave that alone for now. Minus tan theta here, okay? And we're just going to leave that second fraction alone for now. So in distributing here, we'll be multiplying straight across. You have tan theta times tan theta. That'll give you tan squared theta. All of this is going to now be over 1 times tan theta, which is tan theta, okay, minus 1. Okay, because 1 over tan theta times tan theta, the tan thetas would cancel out to leave you with just that 1 right there. Then what I'll do in that second fraction is I'm going to factor out a negative in the denominator. Okay, so this is what I mean by that. See, currently in the denominator you have 1 minus tan theta, but in this denominator you have tan theta minus 1. Well, that's awfully close, right? So what I'll be showing you is that what I can do is I can factor out a negative in the denominator, and I'll be able to rewrite this here as tan theta minus 1 now. Okay, so now I'm showing that I have a common denominator, and now I can combine these. So combining the numerators together, you'll end up with the following. You'll have tan squared theta minus cotangent theta all over tan theta minus 1. All right, and this is what we have thus far. From here, what we want to do is we want to show that using our reciprocal identity that cotangent theta is equivalent to 1 over tan theta. So I'll rewrite this as tan squared theta minus 1 over tan theta all over tan theta minus 1. All right, and what we'll do now is, once again, we have this complex fraction involved. We're going to get rid of that tan theta within that denominator by multiplying each and every term by tan theta. All right, so we're multiplying by 1 in the form of tan theta over tan theta, just like that. So I'm going to distribute this tan theta. At this point, I'm going to go ahead and show them. I get my arrows popping here, all right, but only in the numerator. All right, we're going to take our time with this. We're going to end up with tan cubed theta minus 1. That's multiplying 1 over tan theta times tan theta. Those tan thetas will cancel out to leave it with just 1. And in the denominator here, I'm just going to show that I'll be multiplying that binomial of tan theta minus 1 times this tan theta. All right, so I'll just show that it's tan theta times tan theta minus 1, just like that. All right, so now that I have this, ladies and gentlemen, what I'll be doing now is I'm going to factor this difference of cubes now. All right, and factoring this difference of cubes, we'll end up with tan theta minus 1 times tan squared theta plus tan theta, and this is going to be plus 1. All right, all of this is going to be over our denominator, which is going to be tan theta times tan theta minus 1. So notice that we have identical factors of tan theta minus 1 in the numerator and the denominator. Well, that means we can cancel those out. All right, so they're gone now. So we now have this tan squared theta, all right, plus tan theta plus 1 all over tan theta. Okay, so what we're going to show now is that this tan squared theta plus 1 is equivalent to secant squared theta. So I'm utilizing one of those Pythagorean identities here, all right, to show that tan squared theta plus 1 is equivalent to secant squared theta. And that's going to be plus my tan theta, all right, which is over my tan theta. So that's what I have thus far. At this point, we'll go ahead and expand this fraction. So I'm going to rewrite this as secant squared theta over tan theta plus tan theta over tan theta. All right, so this is what I have thus far. All right, from here I'm going to show that my secant squared theta over tan theta can be expanded to show that it is secant squared theta over 1 times 1 over tan theta plus 1. All right, that's simplifying that tan theta over tan theta. At this point, what I'll do is I'm going to show that that secant squared theta is equivalent to 1 over cosine squared theta. All right, that's using your reciprocal identity. And then rewriting this, knowing that 1 over tan theta is equivalent to cotangent theta, we'll just go ahead and rewrite this now as cosine theta over sine theta. All right, and this is going to be plus 1. From here, what you can do is the following. You can rewrite this by simplifying one of the cosines here. After canceling out one of your cosines, you now have 1 over cosine theta times 1 over sine theta plus 1, which is equivalent to secant theta, using your reciprocal identity, times cosecant theta plus 1, and that's exactly what we had at the beginning of our problem here. All right, so we now have verified the left side equals to the right side. All right, that was a doozy, wasn't it? That was problem number 6. All right, in problem number 7, we have tan x plus tan y divided by cotangent x plus cotangent y, which equals to tan x times tan y. So in this problem, I'm going to change everything in the sine and cosine from the beginning. All right, so looking at this left side, I know that tan x, using my quotient identity, is going to be sine x over cosine x plus sine y over cosine y. All of this is going to be over my denominator, which is going to be cosine x over sine x plus cosine y divided by sine y. All right, so this is what we have thus far. What we'll do now is that in the numerator, we'll get a common denominator and combine the numerators together, all right? And we'll do the same in the denominator as well. So I know that my common denominator is going to be cosine x cosine y, and I'll go ahead and multiply the numerators as well to get equivalent fractions. So this becomes sine x cosine y plus cosine x sine y all over the numerator's common denominator, which is going to be cosine x cosine y. All right, so that's all going to be in the numerator. All right, and this is the result of combining the fractions in the numerator. You'll end up with that after getting equivalent fractions and combining the numerator. That's the end result there. Now in the denominator, you'll do the same process. You'll be adding cosine x over sine x plus cosine y over sine y. So your common denominator in combining these two fractions is going to be sine x times sine y, and then you'll also need to get equivalent fractions and combine the numerators. So you'll end up with the following result. You'll have cosine x sine y plus sine x cosine y, and all of this is going to be over your common denominator for the denominator, which is going to be sine x sine y. All right, and this is what we have thus far. Once you have this set up, ladies and gentlemen, you're going to rewrite this as two fractions dividing. All right. Okay, so now rewriting this fraction here, rewriting this rational expression as a division problem, you'll have sine x cosine y plus cosine x sine y all over cosine x cosine y divided by the denominator here, which is going to be cosine x sine y, all right, plus sine x cosine y all over sine x sine y. All right, so this is what we have going on here. We know that when dividing two fractions, you need to multiply by the reciprocal of the second fraction. So rewriting this, I have sine x cosine y plus cosine x sine y all over cosine x cosine y times the reciprocal of the second fraction, which is now sine x sine y all over cosine x sine y plus sine x cosine y. All right, so now that we have all that worked out, check this out, ladies and gentlemen. Check it out. Do you see it? Do you see it? The numerator of the first fraction is sine x cosine y plus cosine x sine y is identical to our denominator over here. So that means that we can simplify this. These are the exact same terms here. The binomials are identical. Yeah, they're switched around, but it's the same thing. Remember, you have the commutative property of addition going on. So that means that we can cancel that out, and then when multiplying straight across, you'll end up with sine x sine y all over cosine x cosine y. All right, well, using your quotient identities, sine x over cosine x is tan x, and sine y over cosine y is tan y. All right, so that verifies this problem, ladies and gentlemen. The left side now equals to the right side. Done and done. That was problem number 7. Let's move on to our next one. In problem number 8, we have sine of 2 theta equals 2 tan theta divided by 1 plus tan squared theta. Well, we're going to be utilizing a double angle rule in this problem, ladies and gentlemen. That's right. A double angle rule. And yes, I will be working the left side to equal to the right side. So check this out. The first thing I'm going to do is I'm going to use my double angle identity to show that sine of 2 theta is equivalent to 2 sine theta cosine theta. All right, that's going to be my first step. From here, I'm going to show that I have 2 sine theta times 1 over secant theta. All right. Once I have this, from here I'm going to multiply, and I'll end up with 2 sine theta over secant theta. All right. And then from here I'm going to be multiplying the numerator and the denominator by secant theta over secant theta. All right. What this does for me, ladies and gentlemen, is that it allows me to rewrite the numerator here as 1 over cosine theta. So I have 2 sine theta, and I'm going to rewrite that secant theta as 1 over cosine theta. All right. All of this is going to be over the secant squared theta, just like that. Okay. Knowing that I want my numerator to have tan theta in it, multiplying sine theta times 1 over cosine theta is 2 times sine theta over cosine theta. All right. Then utilizing my Pythagorean identity, I end up rewriting secant squared theta as 1 plus tan squared theta. All right. We know using our quotient identity that sine theta over cosine theta is tan theta. So we'll have this rewritten as 2 times tan theta over 1 plus tan squared theta. All right. And this verifies our identity, ladies and gentlemen. We were able to rewrite the left side into the right side. Done and done. So this completes part 2 of verifying trigonometric identities from Fort Bend Tutoring, ladies and gentlemen. I look forward to the next 8 problems. So check out verifying trigonometric identities part 3. All right. And as always, please rate, comment, and subscribe. And if you're able, please donate, as that helps us bring you more free math tutorials from me, Mr. Witt, and Fort Bend Tutoring. Peace.
Thanks for watching. We feel great knowing that you got some help and you're safe and sound. Now, if you'd be so kind as to like this video, subscribe to our YouTube channel, Fort Bend Tutoring, and like us on Facebook, we'd be much obliged.